Hello everyone, welcome to Chem Analysis. Today I will discuss about an important chapter from Stereochemistry which will be applicable for the candidates who are preparing for IIT JAM, MSc Entrance Examination, CSIR NET and GATE examination. And the topic for this discussion is the identification of homotopic, enantiotopic or diastereotopic groups or proton, and along with that I will also discuss about enantiotopic and diastereotopic phase. So let's start this discussion, and before going to main discussion I would like to say that if you are new in this channel then please subscribe to my channel. First of all, I will discuss about homotopic protons or groups. That is, homotopic protons or groups are that type of groups that can be interconverted through a axis of symmetry present within the molecule, such as if we consider a compound like this one. There will be two hydrogen atoms, and if we draw one hydrogen atoms as yellow and the other one as green, then we can see that this molecule contains a C2 axis that will pass along this bond, and if we rotate this molecule along this C2 axis, then it will result in the formation of the compound. That is, this OMe group will come here and this will go there, and the hydrogen atoms will interconvert between them. That is, the yellow hydrogen atoms will go above the plane, that is this one, and the green hydrogen atom will go below the plane, that is this one. That means by only operating C2 axis we can see that these two compound, that is if we number is as A and this is B, then we can see that these two compound can be interconverted through a simple C2 axis of rotation, and for that reason we can say that these two hydrogen atoms, that is if we number it HA and HB, HA will be equal to HB and they will be homotopic proton. Is it clear? We can think in another way, that is, at first if we substitute HA by another group like this one, if we substitute HA by another group, suppose Cl, and the HB remains as it is, and similarly if we substitute the HB by the same group as we substitute HA, that is if we substitute HB by Cl atom, that is in the second case the Cl atom will be above the plane and below the plane will be HA, and if we ignore the notation A or B, that means these are two only hydrogen atoms, then only operating C2 axis, if we operate C2 axis, then we can convert the A prime to B prime. That is, if we operate C2 axis, then this OMe group will come here and this will go there, and Cl atom will go above the plane and hydrogen will go below the plane and will result in this compound. So we can say that in this case both the hydrogen atoms are homotopic protons. Is it okay? That means we have to first see that the molecule contains any symmetry axis or not, and if the molecule contains symmetry axis and after operating that symmetry axis, the desired groups which we are going to identify that the relation between them, if they can be interconverted to each other, by only rotation axis, then we can say that both the groups are homotopic groups. Now let's see enantiotopic groups or protons. Similarly, during the consideration of enantiotopic protons or enantiotopic groups, we have to first see that the molecule contains any sigma plane or not. That is, the groups will be related to each other through mirror image relationship. Let's try to understand with an example. If, like previous one, if we change one OMe group by another group, as like this one, if we change the OMe by phenyl group and similarly put the two hydrogen atoms, that is, one is below the plane and another is above the plane, here we can see that the molecule does not contain any C2 axis or any other symmetry axis. So these two hydrogens cannot be interconverted to each other through any axis of symmetry. Here we can see that there is a sigma V plane passing through this OMe center carbon and phenyl group, and that will bisect these two hydrogen atoms and make these two hydrogen atoms enantiotopic. On the other way, if we consider a mirror plane, that is, in this compound, if we think about a mirror plane, we will see that the compound will be converted into and that mirror plane will transfer this below hydrogen to above the plane, and the above hydrogen will go below the plane. That is, the hydrogen which is below the plane will go above the plane, and the hydrogen which is above the plane will come to below the plane. That means we can see that these two hydrogen atoms, if we number it H and Hb, these are interconverted to each other through a mirror plane or sigma plane, and for this reason we can say that these two hydrogen atoms are enantiotopic to each other. Okay, similarly, as like previous one, if we substitute one of the hydrogen atoms by a group, that is, if we substitute the below hydrogen by chlorine atom, and similarly in the other case if we number it as A, and similarly in the other case if we substitute other hydrogen atom, that is, which is above the plane, by the same ligand, that is chlorine, and the other hydrogen atoms will remain below the plane, and we can see here that if we operate a sigma plane, that will pass containing this OMe carbon and phenyl link, these two compounds can be interconverted to each other, and during the operation of sigma V plane, the below chlorine atom will go above the plane and the above hydrogen atoms will go below the plane. That means these two A and B can be interconverted, and here we can also see that A and B are enantiomer to each other. Since after substitution of one hydrogen atoms between the two we are generating a enantiomeric pair, so we can also say that these two hydrogen atoms are enantiotopic in nature. Now next see the diastereotopic protons or diastereotopic groups. In this case, the two groups which are in consideration will be related to diastereotopically. That means if we see like this one, if we change the phenyl group like other chiral center, as like this one, this is one chiral center, and if we think about the hydrogen atoms as like previous one, if we number it as HA and this as HB, then since there is a chiral center within the compound, now if we go through the second pathway, that is substitution of one hydrogen atoms to another ligand, that is if we substitute HA by chlorine ligand, then the compound will result as this will be HB and chlorine will be below the plane. And similarly, if we substitute the HB by the similar ligand, chlorine ligand, we have to substitute the two groups simultaneously by the same ligand, otherwise the comparison cannot be done. There will be chlorine atom and this will be hydrogen. Now we can see that these two compounds, if we number it as A prime and B prime, if we see the specific stereochemistry of this center, then we can see that this will be 1 2 3, that is clockwise rotation, and least prior group is below the plane, so it will be R, and similarly this center will be also R. And now since the chlorine atom in this case is below the plane, if we see the stereochemistry of this center, then we can see that this one will be 1, this will be 2, and this will be 3, and the least prior group will be this one. And in this case the rotation, that is 1 2 and 3, if we draw it in Fisher projection, then orientation of the groups at this carbon center will be, that is hydrogen will be along the vertical axis and above the axis, and Cl will be below the axis, and OMe will be on the left side, and this group will be on the right side, and the numbering is 1 2 3, and hydrogen atom will be 4. So the rotation is 1 2 3, that is clockwise, so the stereochemistry of this 2 center 1 2 carbon is R. And similarly in this case we can see, and if we draw it in Fisher projection, chlorine will be vertical and hydrogen will be in vertical axis and below, and OMe group will be on the left side, and this group will be on the right side. So it is 1 2 3, and the least prior group is hydrogen. So the rotation here we can see that 1 2 3 is anti-clockwise, so it is S. That means the substitution of the hydrogen atoms at this center resulted in the diastereomeric pair, that is one is RR and another is SR, and these two are diastereomer to each other. So we can say that the two hydrogen atoms are diastereotopic in nature in this case. Is it okay? Since there is a chiral center within the compound, so the two hydrogen atoms present within the molecule in presence of this chiral center must be diastereotopic. Okay, now let's see some example, and another example of this diastereotopic group, let's see this one. Just if we erase this, that in this case we can see that there is a chiral center, and this center is chiral center, since the 4 group attached to this carbon is different, so this is chiral center. And in presence of this chiral center, the remaining carbon centers which contains two hydrogen atoms, both the hydrogen atoms will be diastereotopic. And in this case we can see that the black hydrogens and the green hydrogens are related diastereotopically, that is they are diastereotopic in nature, that is they are diastereotopic protons. Similarly, this hydrogen will be diastereotopic, and this hydrogen and these hydrogens are also diastereotopic. And if we consider these two methyl groups, then these two methyl groups will also be diastereotopic, since these are within a environment of a chiral center. Okay. Now let's see some example related to this discussion. If you are given a compound like this, and here is chlorine above the plane, hydrogen is below the plane, and at this center hydrogen is above the plane and chlorine is below the plane. Now we have to identify the relation between these two hydrogens. If we number it as HA and this one HB, then what is the relation between these two groups? Now first of all we have to see that the molecule contains any axis of symmetry or not. Then we will think about any sigma plane, that is for the enantiotopic nature, and later we will go for the diastereotopic nature. Here we can see that there is a C2 axis passing, that is this carbon, and if we rotate the molecule along the C2 axis, then the compound resulted will look like that this portion will go in this side and the left portion will come on the right side, and this will look like, that is the below chlorine will go here and above the plane, and the above hydrogen will go below the plane, that is HB will come here. And here that if there is two hydrogens, and they will also rotate their position. If this is HC and this is HD, if HC is above the plane, here HC will go below the plane, and if HD is below the plane, it will come here as above the plane. Okay. And similarly this portion will go to the right side, and the chlorine which is above the plane will go here below the plane, and the hydrogen which is below the plane will be here above the plane, so it will be HA. And this one will be the structure resulted from the C2 rotation. And here we can see that if this is X and this compound is Y, we can say that this X and Y are identical. So we can say that this HA and HB are related to homotopically to each other, that is they are homotopic protons. Is it okay? Now let's see another example. If you are given a compound like this one, that is here is bromine atom which is above the plane, and hydrogens I am numbering is as HA, and similarly the bromine atom is below the plane, and hydrogen atoms which is numbered as HB is above the plane. We have to identify the relation between HA and HB. Similarly, first of all we have to see that there is any symmetry axis or not, and we can see here that there is a C2 axis passing along this, that is this carbon and this carbon atom, and if we operate the C2 axis, then the resulted compound will look like, that is this portion will go on the left side, and the bromine atom which is above the plane will go below the plane, and HA which is below the plane will come up as above the plane, and similarly Hb will go below the plane, and bromine atom which is below the plane will come as above the plane. So we can see that if it is M and if it is N, we can say that M and N are identical. So HA and HB will be also identical and they will be homotopic. Okay. Now if you are given such compound, both the hydrogen is below the plane and both the chlorine atom is above the plane, and here we can see that there is no axis of symmetry. We cannot see in this compound any axis of symmetry. Okay, you can think by yourself that there is no axis of symmetry by which we can interconvert these two hydrogen atoms or these two chlorine atoms. And next we have to think about any sigma plane, that is the molecule contains any sigma plane or not. Here if we see carefully, then we can see that there is a sigma plane, sigma V plane, which will pass along the middle of this carbon-carbon bond containing this carbon atom. There will be sigma V plane, and this sigma V plane will interconvert between these two hydrogen atoms. That is, the HA will go on this side and HB will come right side, and the chlorine atom, the chlorine X will come here and chlorine Y will go on the left side. So we can see that is these two hydrogen atoms are interconverted through a plane of symmetry. That means they are related to each other through mirror image relationship. And on the other way, if you substitute this HA by another group, that is if you substitute by G, suppose G is some group, and similarly in the next step if you substitute this HB by the same group, that is by G, then we can see that this M and M prime, if we number it like this, then we can see that this M and M prime are related to each other by a mirror plane. That is, if we pass a mirror plane, then M can be interconverted to M prime. So these two hydrogen atoms are HA and HB are anisotropic in nature. Enantiotopic protons. And these two chlorine groups are also enantiotopic groups, since they are also related through a sigma V plane. Now let's see another example, that is this cyclopropene. If there is two hydrogen atoms at this carbon, and if here is one chlorine atom which is above the plane and the below the plane is one hydrogen atom. If we have to identify the relation between this HA and HB, then we can see here that there is a sigma plane passing through this carbon atom containing this chlorine and hydrogen atoms, and at the middle of this carbon-carbon bond. So we can see here that these two HA and HB are interconverted through a sigma V plane passing through this atom. So these are anisotropic protons. Okay. Now if we consider such compound and there is one chiral center, that is this one, and if we are asked to identify the relation between HA and HB, then we can say easily that since there is a chiral center within the compound, so these two protons will be related to diastereotopically. So these will be diastereotopic protons. If you substitute HA by a other group, that is bromine, and in the other case if we substitute the HB by the same bromine group, then the compound resulted will be diastereotopic to each other, as I shown in the starting discussion. So they will be diastereotopic protons. Now if we consider the non-bonding case, that is here one hydrogen is XO, this is XO, and this hydrogen is endo, and in case of such bicyclic molecule, this XO and endo protons will be always diastereotopic. These are diastereotopic protons. Now the question is how we can separate or identify enantiotopic, diastereotopic or homotopic protons by experiment. Now for this, let's see some example, that is differentiation between enantiotopic and diastereotopic protons. Here we can see that there is no chiral center within the compound, and these two green hydrogens will be chemically equivalent as well as magnetically equivalent, and similarly these two hydrogen atoms will be also magnetically equivalent, and these green hydrogens will be enantiotopic to each other, and similarly these two brown hydrogens will be also enantiotopic to each other, and that can be seen in the NMR experiment. That is, the chemical shift value for these two green hydrogens will be at the same ppm value, and for these two hydrogens, brown hydrogens, will be at the same chemical shift value. And we can see that these two hydrogen atoms are coming as singlet as this 3.9 ppm, and since they are equivalent, they will not couple to each other and they will appear as singlet, and similarly these two brown hydrogens will also be chemically equivalent and they will also appear as singlet at 3.1 ppm value, and this peak is corresponding for the 5 hydrogen atoms of phenyl. And similarly, now if we substitute one of the hydrogen atoms by another group as like methyl, now here due to substitution of one hydrogen atoms by another group, there is a generation of chiral center, and for the generation of such chiral center, these two protons in this case will not be enantiotopically related, and these two protons, this green and light brown protons, yellow proton, will be related to diastereotopically, and the chemical shift value for the diastereotopic protons, since they are magnetically non-equivalent, they will appear at different chemical shift value. As we see in the NMR spectrum for this compound, we can see that this green hydrogen and this light yellow hydrogens are appearing at different chemical shift, and this pink hydrogen is appearing as a quartet by coupling with this 3 methyl proton, and this yellow methyl group appearing as doublet by coupling with this pink hydrogen. In this case, the frontalin molecule, we can see here that this pink hydrogen and these green hydrogens will be diastereotopic in nature, since there is 1, 2, there is chiral center, 2 chiral center within the compound, so these two protons must be diastereotopic in nature, and in NMR spectrum they will appear at different chemical shift value. So if you see the NMR spectrum, we can see that this hydrogen is appearing as doublet by coupling with these green hydrogens, and similarly these green hydrogens appearing at different chemical shift value as a doublet by coupling with this pink hydrogens. So by such experiment, that is by NMR experiment, we can differentiate between enantiotopic and diastereotopic groups or protons. And since the homotopic protons or groups are identical in nature, they can be discriminated from diastereotopic protons from NMR spectrum or NMR experiment, but the enantiotopic and homotopic protons cannot be discriminated by NMR spectrum. So that's all for the enantiotopic, diastereotopic and homotopic groups or protons. Now let's see enantiotopic phase. Now such carbonyl compound, this is planar compound, and there is two plane, that is if a nucleophile attack at this carbonyl carbon, that nucleophile can attack from top face or from below face, that is bottom face, and the compound resulted by the attack from the top face and from below face will be enantiomer to each other. Since if ethyl magnesium bromide reacted with this carbonyl, the ethyl group will attack from above the face, the compound resulted will be R, and similarly if ethyl group attacks from below the face, then the compound resulted will be S. And since the compounds are enantiomer to each other, so this type of phase are named as or are called as enantiotopic phase, since they are resulting a enantiomeric pair. And similarly, and since in this case the compound is already containing a chiral center, and the attack at this carbonyl carbon, that is if a nucleophile attack from above the plane or below the plane, will resulted a diastereomeric pair. Now let suppose this chiral center, if we see the stereochemistry, then it will be 1 2 3, that is clockwise rotation, but hydrogen is horizontally, so it will be S. And now if any nucleophile, depending on the priority of the nucleophile with respect to the other groups present at this carbon center, if the attack from above the face resulted the chiral center of this carbon as R, and the attack from below the face must result the stereochemistry, that is inversion of stereochemistry, since this phase is enantiotopic in nature. So the attack from below the face will convert this center to S stereogenic center, and and this chiral center will remain as S. So the compound resulted are RS and SS, and they are diastereotopically related, so this phase is called as diastereotopic phase. Is it okay? So that's all for this discussion, and thank you for watching. And if you are new in this channel, then please subscribe to my channel to get such important information related to different topic. Thank you.